In today's episode, we are going to be performing sentiment analysis on news articles using the TextBlob Python package. Follow along to this episode to see how you can make a difference with natural language processing and text analysis. Let's get started. Hello, my name is Rohak and I'm the founder of Empower Code, helping you make a change with technology. Today marks the 11th episode of my course, Data Science for Media Bias Detection, where I'll be teaching you how to perform newspaper sentiment analysis in Python in just a couple short lines of code. What are we waiting for? Let's get started. Alright guys, to start off, I have just opened the PyCharm IDE, and if we go ahead and right click our project folder, select new, and then Python file, we'll come across this prompt. After entering our file name, which is newsnlp.py, we can simply click enter, and now we're all set and ready to go. To start off, let's copy over a sample news summary about the harmful consequences of ransomware. We'll use this later to test and run our code upon. Additionally, at the top of our code, we can use the from keyword, then specify TextBlob because that's the package we're going to be using. And then inside, we're going to be able to import the actual TextBlob class that we're going to be using to do sentiment analysis with. Now, the first thing we're going to do is we're going to create a new function, findSentiment, which takes in a given news story as a parameter. What this method will do is it'll return the accurate sentiment, polarity, and subjectivity of a given news story. Now inside our method, let's create a new variable, call it news. Then we're going to set this to a new TextBlob object containing the news story that was passed in as a parameter. Alright guys, in efforts to start experimenting with some of TextBlob's functionalities regarding sentiment analysis, I created a simple for loop which iterates over each sentence in news.sentences and simply prints out the sentence. So let's go ahead and run our code to see what we get. After calling our function and running our code, we can see individual sentences printed on each line. This is really cool, and now we're going to perform individual sentiment analysis on every one of these sentences. So, enough of me talking, let's get right into it. Okay, now that we printed out the actual sentences themselves, we're going to actually use the sentiment method of a TextBlob object to get the sentiment of each sentence. So, we simply write sentence.sentiment, and let's see what we get. Running our code, we see a bunch of data presented before us. So let's try to break this down in the most understandable way possible. So here at the top, we see a sentence, and then below it, we see a given sentiment object. Now inside of this sentiment object, we see two fields or values, polarity and subjectivity. These are extremely common to see when it comes to sentiment analysis, so it's important to know what they mean. Polarity quantifies whether a statement is positive or negative, and subjectivity generally refers to personal opinion, emotion, or judgment. So as you can see in all of our values, polarity is a float which ranges from -1 to 1. -1 being the most negative and 1 being the most positive. And subjectivity is always positive, and it's a float that ranges from 0 to 1. 0 being the most neutral and objective, and 1 being the most subjective or biased. So this is what our data means. Now how can we use it? Well, let's go ahead and find out. So now that we're done with our experimentation, we can go ahead and delete these two lines and start fresh. Now the first thing we're going to do is we're going to assign a new list called sentiments, initialize it, and set it up at the top. This is because we're going to compile a list of all the sentiments inside of each individual sentence. So now inside of our for loop, we can create a new variable called sentiment and assign it to sentence.sentiment like we did previously. And so inside of each sentiment, as you guys saw, let me pull up our output again. We see that there's two fields, right? So there's polarity and there's subjectivity. So we need to be able to extract both of these fields and store them in a list. So we're simply going to iterate over every single metric inside of our sentiment, and then we're simply going to append that to our sentiments list. So here in our sentiment list, we can simply append our metric. Now, after we go ahead and run our code, we see a bunch of values in our sentiments list. So we see that polarity always comes in every second value. So for instance, negative 0.3 would be polarity, 0.2 would be subjectivity, this would be polarity, subjectivity. So we see this common pattern in our list, and it extends all the way through. So using this, we can now segment our data into individual lists containing polarity and subjectivity data, respectively. Awesome, now we've created polarity and subjectivity data lists, respectively. And so what we're going to do is we're going to use a for I in range loop. This is very useful, and we're going to iterate over the length of our sentiments list that we previously were able to extract. And so now we need to check if I is even. And the reason we need to do this is because of the pattern we noticed earlier. All of the polarity values lie on the even indices of our list. So the way that we can check if I is even is we can simply write I modulus 2 is equal to 0. If this test is true, that means the indice is even and we can append it to our polarity list. So now we can select our polarity data list and go ahead and append sentiments at the index I. Now we have our polarity data sorted and ready to go. And if it's odd, we can also append that value to our subjectivity data list. And so now after doing this, all our data should be set up and ready to go. Now let's go ahead and print our polarity data and subjectivity data to the console and see what we get. Awesome guys, the list at the top is all the polarity data that we need, and the list at the bottom is all the subjectivity data that we need. Now that we have these values, we can do a lot with them. Now, in case we need to check if the values of our list are actually correct and sorted correctly, we see that all the polarity values actually range from -1 to 1, whereas all our subjectivity values stay positive. This is a key indicator and lets us know that we're sorting our data correctly. Now, by using a simple sequence of for loops and some inbuilt text plot fields and instance variables, we have acquired the overall polarity and subjectivity data from our news story. Now, with all our data gathered, we need a way to make sense of it all. So here I've created a new helper method, calculate average, which will simply calculate the average of all our values in each of their lists for polarity and subjectivity data, respectively. After passing in a list as a parameter, we can simply return the sum of our list divided by the length of our list. This will give us the average that we need in order to complete and get our average for both lists. Awesome. On lines 30 and 31, as you guys can see, we assigned two new variables, polarity average and subjectivity average, using our calculate average method with our lists passed in as parameters. Awesome, but we aren't done just yet. The final step of our script has to do with fine-grained sentiment analysis. We need a proper way to categorize and quantify different intervals of our sentiment data for both polarity and subjectivity. Awesome, I've now created a new method called calculate sentiment, and it takes in the average sentiment as well as the type of sentiment, which would either be subjectivity or polarity. Now, to save us some time, I went ahead and finished this entire method so that we can spend more time reviewing and analyzing this code. So how does this all work? There are a whole lot of if statements, but don't worry, I'll try to make this as understandable as possible. So at the top here, I created a new variable called sentiment category, which will serve as the return string representing the category of the given sentiment. So here I tested if the type was polarity, and down here I tested if the type was subjectivity. Now, depending on the type of sentiment, I had a different classification system put in place. So for polarity values, as you can see, the values range from 0.75. So if the sentiment is greater than 0.75, this will be the highest category possible. And if the sentiment is less than -0.5, this will be the lowest category possible. So notice that these intervals range from -1 to 1. This is super important because we're dealing with polarity data here, not subjectivity data. But if we go down here to subjectivity, we see that our values are only floats between 0 and 1. This is extremely important, and it was integral to the completion of these if statements. And notice that we assign different value for a sentiment category depending on its classification and category. And finally, if the user enters a type other than polarity or subjectivity, we simply print invalid input. So now let's go back to our find sentiment method and incorporate our new method inside of our code. So first, let me type in some print statements that'll preface our final analysis. Awesome, so here I created some cool print statements that read final analysis followed by a bunch of small dashes. So here, this is our first statement for our polarity data, and inside we can use our calculate sentiment method, and inside we're going to pass in the polarity average that we calculated earlier, and we're going to specify the type as polarity. And now we can simply repeat the process for our subjectivity data. So here we can simply call our calculate sentiment method, and then pass in our subjectivity average, and also specify the type as subjectivity. Now we're all ready to go. Let's print our data to the console and see what we get. Awesome, after running our code, we can see that we yield a neat and clean final report of the polarity and subjectivity levels in the news story that we passed in. Now that is awesome. Additionally, if we actually analyze the analysis and see if it's right or not, we can see that it is actually very accurate. Looking at this article, it seems very negative and bashing regarding the harmful nature of ransomware attacks, so our polarity is slightly negative. And our subjectivity is extremely objective since this article is purely factual. It simply states the facts and displays them in a comprehensive article review. So I feel pretty confident in our analysis system. By using Python fundamentals, we were able to perform sentiment analysis on news stories. This is what code is about, having fun and learning all along the way. In the coming episodes, we will be building a news aggregator all from scratch. If that sounds interesting, stay tuned and follow along. You won't want to miss out. Soon, we will be able to effectively extract metadata and successfully detect news bias on New York Times technology-related articles. How cool is that? Once again, if you still have doubts or confused, the script we wrote together is stored on GitHub. Check the description to access the link to it. Once again, thank you so much for watching. Take care, and I'll see you in the next episode.